Hello, good evening, students. Welcome to my channel Smart Codings. Today we're back again with another video. We'll be teaching you today binary search, right? So it's a new search technique which is used to solve the problems of linear search. There was a problem of linear search I have told in the last video, students, that when the search list is array list is big or it goes bigger, then element to be searched it takes more time because the element to be searched is checked with all the elements of an array, is compared with all the elements of an array, and as the array list gets bigger, it takes more time, so which hampers the performance of the search. So to solve that problem, we Java has another technique of searching, that is a binary search, right? So let's get started with the binary search. And as you can see in the screen, there are a few points written regarding binary search. It is a technique to search an element in the given array in a minimum possible time. First point is this, because it uses a divide and conquer principle. So I'll be explaining you the working principle of binary search in the next slide. Data item must be in sorted order. The main point of this search is of this technique, searching technique, is data must be in sorted order. It is based on the principle of divide and conquer. Okay, searching technique is fast as compared to the linear search, as because it based on the principle of divide and conquer. An array is divided into two halves as the search area becomes small. That is, the search space of search area becomes small. So this is what is the binary search, right? Now the main advantage of using this search technique is it is the fastest search technique as compared to the linear search, right? Now let's go to the algorithm. Every search or every programming has its own algorithm. First, we need to figure out the algorithm first. That is the stepwise instruction, how it works, before we move on to the working principle on the program. So as you can see, we need to start from a mid element or the middle element. Now if the target value, that is the element to be searched, is equal to the mid element of an array, then it will return the index of the mid element. As you know, the array has an index, it will return the index of the mid element. That is, if the data, that is the element to be searched, that is the data, is equal to the mid, then it will return the mid, right? Now if the target value is greater than the mid of an array, then we'll search in the second half of an array. That is data greater than a of mid, then we'll change the first index equal to mid plus 1. I'll demonstrate you the working principle very soon. And if the target value is less than the mid of an array, then we'll search in the first half of an array, that is data less than a of mid, that is we'll change in the last index equal to mid minus 1. So through this algorithm we will apply the searching technique, and we will do the programming. Now all these steps, this one, this and these three steps will do as long till the first index is less than the last index. If the first index becomes greater than the last index, then we'll not search, and it indicates that the element is not found in the array list. So quickly see the working principle here. Now suppose see as array name is A over here. Now the array has total 8 elements, 0 to 7, that is 8, and 2, 4, 6, 8, 10, 12, 14, 16 are the elements of an array, and 0, 1, 2, 3, 4, 5, 6, 7 are the index of an array. Now first index, that is fi, last index, that is li. In this working principle I have demonstrated the first index as fi and last index as li. Sorry. So first index plus last index, that is 0 plus 7. 0 plus 7, that is coming 3.5. It will take the floor value, that is only 3. That 0.5 it will not take. Compiler will take only the 3. This 3, that is the floor value it is. Okay. Now 3, that means this one, this one. You see the cursor over here. 3 means this one, that is the 8. 8 becomes the mid. Now suppose element to be searched is 10. I have highlighted the element to be searched with the green color. That is element to be searched is 10 over here. So check the data, that is the element. It is greater than the mid. Yes, 10 is greater than the mid. Then we will search the right side of an array. That is the right part of the mid. That is from this one, from here till here. This is the right side. right half of an array, and this is the left half of an array. Okay, this is the right half of an array, and there is the left half of an array. Clear? So we don't need to search about this side. So search space becomes small now. See, we are only focusing on this part, and we know that the element 10 will be in the right side of the array because array is in sorted order. Binary search won't work if the array is not in sorted order. Binary search will work only when the array is in sorted order. Keep in mind. Now, element to be searched that is 10 greater than the mid will check in the right side of an array. Now see, first index was 0, last index was 7, the mid was 3.5. It will take the floor value, that is 3. Now 3, that means 8 is the mid value. Now 10 greater than 8, element to be searched 10 is greater than the mid value. Okay, so we'll search in the right side of an array. Okay, now step 2. Okay, now right side means the new index will be this one. First index will be mid plus 1, that is 3 plus 1, that is 4. First index will become 4 now, last index will be as it is 7. Now 4 plus 7 by 2, again we'll calculate the mid. So it is coming 5.5, it will take the floor value, that is 5. This 12 becomes the mid now. Mid I have highlighted with a yellow color. So 12 becomes the mid now. But element to be searched 10 is less than the mid. So we'll search in the left side of an array, I mean in this side, in this part. Okay. So first index will be as it is 4. Last index will change. That is mid minus 1. Mid was 5. 5 minus 1, that is 4. So now first index 4, last index is also 4. Again calculate the mid. Divide by 2, that is coming 4. So first index and last index pointing to this index only, that is here, to this mid over here. Now, so we'll return the mid index of the mid, that is 4. So as long as the first index is less than the last index, we'll continue the search. Okay, but if the first index is greater than the last index, it indicates element is not in an array list. Okay, so this is how the working principle. The main funda is data, if it is equal to mid, then the element is found. But if the data to be searched, the target value is less than the mid, then element is in the left side of an array, and if the data is greater than the of mid, we'll search in the right side of an array. I repeat once again, if the data, that is element to be searched, is equal to a of mid, that means we'll return the index of the mid. Data is already found then. But if the data is less than a of mid, we'll search in the left half of an array. If the data is greater than a of mid, we'll search in the right side of an array. By this way, the search space becomes small, the search technique becomes fast, and this total working principle is based on divide and conquer. So this is how it works. So if this video is useful, students, please do like, share and subscribe. Any doubt, do comment in the YouTube comment section. Now let's quickly go to the BlueJ and write a code of binary search to show you how it works. Binary search to show you how this program works. So already I think it is there with the, in this binary search is already there. Binary, let us give binary demo here. Let us give binary demo over here. Okay, now this becomes the documentation part. Leave it as it is, or let us remove all these things. Now, before I start writing the code, I will be telling you, students, that at first we need to take the input for the scanner class. For that we need to import a package here, that is import to use scanner class java.util.scanner, right? So this is for the scanner class, package is imported, class binary, then the main method over here, public static void main string args. This is the main method. Now we'll create an array, suppose int a equal to new int. Let us give the size as 5. Fine. Array creation done. Stepwise I will show you. So and let us take a variable over here, f equal to 0. That is the first index we should initialize. Okay, and last index L, suppose total length minus 1. There's a total length, there's a dot length, as the array name is a dot length minus 1 is the last index initialization. Total length minus 1, that is become the last index. Okay, and one more value we need, mid. Fine, variable declaration done. Let us take here small m only we should take. Okay, now we'll take a boolean value over here. Boolean, it's a flag is an indicating bit. Let us initialize this flag with false first. Initially flag equal to false, flag equal to false over here initially. Right, now it indicates now search has not yet started, element is not found now. Okay, once the element is found, we'll make flag values true. So it's indicating bit over here. Now let us create an object of scanner class, scanner sc equal to new scanner system dot in. Right, so object creation done. Now we'll print a message to the user, system dot out dot println, enter 5 elements, enter 5 elements. Okay, so this is what is enter 5 elements into an array. I hope this is clear. Now we'll using a loop, we'll take input int I equal to 0, I less than a dot length, a dot lengthwise students, total length minus less than, starting from 0 to less than the total length, that is the a dot length. Total length is a dot length, total length of the array is a dot length, and 1 less than the total length. Okay, so if the total length is 5, so 0 to 4 it is. I hope it is clear. I plus plus, I plus plus. So with this we'll be taking an input to the this array a of I equal to sc dot next int. Now we'll copy this, enter the element to be searched. We'll copy this line, no need to every time write it. Let's do a smart work a bit. Enter the element to be searched, enter the element to be searched. Right, enter the element to be searched, int s equal to sc dot next int. So s variable we're taking to store the element to be searched. Right, now this is done, this is done. Now we'll use a loop over here, while loop. I've told you we'll continue the search as long as the first index, that is f, is less than last index. Okay, now we'll calculate the mid inside the loop, that is m equal to f plus l to, now we'll check what, we'll check with the condition. Now we'll check with the condition. What condition, student? So as long as this first index is less than the last index, then we'll continue the process. First need to calculate the mid. Once mid is done, and if the element is found in the mid itself, then we'll return the mid over here. So we'll check over here to check if s equal to a of m, a of m. Right, so what we'll do, students, we'll print over here. Let's copy this one second statement. I'll write over here system.out.print element found at, element found at index, right, plus m, that is at mid, that is data equal to a of mid, that is data is stored in s variable. I hope this is clear. Now what next? So once this is found, we'll make the flag value as true to indicate that already search is done. Flag value is true. Now we'll stop the search using a break statement. I'll close the braces. This part is closed. Now if is closed here. Now else if, another condition, else if. Now, if the element to be searched, that is in S, that is the data, that is the target value, is greater than the A of mid, is greater than the A of M it is in the program. So what we'll do, we'll change the first index, that is F equal to M plus 1. According to the algorithm, just now I have said, if the data to be searched is greater than the mid, we will change the right side of the array, that is first index equal to mid plus 1, that is M plus 1. If it is just the opposite, else what we'll do, students, that is mid minus 1, that is mid minus 1. So let us write over here L equal to M minus 1. It's very clear. If the data to be is in the mid itself, so we'll print it the mid, return the index of the mid, flag equal to true, and break. No need to search anymore because our search is already done over here. But if the data is in the to be searched is greater than the mid, we'll search in the right half by changing this position of the first index, that is mid plus 1. And if it is less than the mid, we'll change the last index, that is M minus 1. So this is done. Now let us close this one, while loop part. Now outside the while loop, we'll write over here if flag value equals to true, sorry, false, that means the first index is greater than the last index. This entire working we are doing as long as the first index is less than the last index. But if the first index is greater than the last index, it is indicated by flag equal to false. That means element is not found in the array list. Now let us copy this, element not found in an array list. So let's give a enter here, element, let's change here, element not found in an array list, right? So we'll close this main method, we'll close this class. So let us compile this. If any error, we will sort it out. So let's compile it. Okay, in one sorted is no error. So let us take few elements over here, binary demo, right click on main method. Let's take some elements, suppose 10, 20, 30, 40 and 50. Element to be searched is suppose 40 at index 3. So 0 index, 2 index, 3 index and 4th 0, 1, 2 and 3 index. 0th index, first index, second index, third index. That is the element to be found at 40. So let us change over here. One thing I have missed it. So we'll write over here element found at index. So not enter, sorry, it is element found at index. Element found at index, that is the mid. Okay, so save it, compile it, close this one, right click on this main method. Then let us take the input 10, 20, 30, 40 and 50. Let us search for 40 over here. Element found at index 3. So if any other element we want to search, let us show you that also. 10, 20, 30, 40 and 50. Let us suppose search 60. Element not found in array list. So this is how the binary search works. So let's go back to the code once again. What we are doing basically, first we are taking 3 variables over here after creating the array. That is first index 0. If we not initialize, it will say it must be initialized, compilation error. And the last index, the total n minus 1 and the mid m. Okay, and flag value is indicating bit, which indicates false. The search has not yet started or element is not found yet. Now using this, we are taking the input, and what the element to be searched is stored in the variable called s. Till this much is very clear. Now the main working principle start from here. So we'll start the search as long as the first index is less than the last index. We'll search it. If it is in the mid, we'll return the index of the mid in this, and we'll make the flag value as true and stop the search. If the data to be searched, the element is greater than the mid, we'll search in the right half by first index equal to mid plus 1. If it is less than, we'll last index equal to mid minus 1. But if flag equal to false means that is the first index, it becomes greater than the last index. Then the element is not found in array list. This is how it works. So students, if this video is really useful, kindly share it, subscribe it, any comment, Any doubt, do comment in the YouTube comment section. Thank you, students. Take care.